Okay, this is a continuation of section 2.1 from MAC 1105. We were in the process of comparing graphs, and we had graphed the parent graph, which came from these points. Then we were discussing how to recognize that this is a vertical shift, and vertical shifts only act upon the Y value. I mean, in essence, they are what they imply. When you're doing a vertical shift, you're moving either up or down with respect to the y-axis. So if you know that you're going to carry out a vertical shift, and you'll know that because the number will not be in parentheses with the x. So you're going to use this number on this table that's called the parent graph. This is the parent graph, a graph that has the shape but nothing added or multiplied. So you're going to take this graph, leave the x's alone because you're only doing a vertical shift, which is only about changing the y values. So you keep all the x values the same, -1, 0, and 1, and then you take the y values from the parent graph, and instead of plugging all of these x values back into this new function, you're just acting upon the y values with that vertical shift. So vertical shift is +5. It's just 1 + 5, 6. 0 + 5, 5. 1 + 5, 6. So you have this new set of points on your shifted graph, which is called the g of x graph. Okay, so here you have the parent graph. This was the f of x function equal to x squared. And then you have the new graph, g of x, which was just simply these points plotted, -1, 6, 0, 5, and 1, 6 to get this new graph, which was x squared. Then you're going to be asked to describe what is the difference between the two graphs. That's what it means to compare two graphs. This graph is shifted 5 units up. So what has happened? A vertical. That's what it means to move either up or down. A vertical shift of +5. It's moved 5 units up with respect to the parent graph. Okay, looking at the graph below, where basically the same thing is happening, only there are more things happening in this problem. Just to get you to understand the problem we just did, I was pointing out that sometimes there is a number included with x inside parentheses, and that's your clue that you are being asked to horizontally shift the graph, which means to slide it from left to right. The only thing that you do have to remember is that horizontal shifts behave the opposite of the way they appear in the equation. So if you're seeing a -3, now this is only for horizontal shifts, not for vertical shifts. If you're seeing a -3 inside the parentheses with the x, which is your clue that it's a horizontal shift, you will really be using a +3. Okay, don't forget to switch that sign when you're doing a horizontal shift. So just like we did the last problem, we'll do a very simplistic parent graph, just the shape that's in both of these problems. They're both parabolas because the square is on the x. Notice the square is on the x here. So we'll do a very simplistic parent graph, a table that goes with just x squared. And then instead of taking all of our chosen x values and plugging it into this function, which is much more complicated algebraically, we're just going to work off of our knowledge of horizontal and vertical shifts. We're going to do this to our x's in our parent graph, and this +4 is the vertical shift. Notice that when there's one number that's not inside the parentheses, this one, it's a vertical shift, and there's one that is inside the parentheses. So this is something that works on the x values, which is why they're hanging around together in a parenthesis, but it gets switched. And then the vertical shift, you don't switch the sign, you use it as is, and you act upon the y values. I guess you should say for the new graph. Okay, but if you're going to do these things, act upon the x's or act upon the y's, you need to know what the numbers are on the parent graph so that you can avoid having to plug the numbers in all over again. And instead, you can just take the parent graph. Here's my parent graph. X's and Y's, the function that I'm plugging in here is f of x equal to x squared. I'm looking at that right there. And I'm going to plug some super easy numbers, just like I did when I did the previous problem. I'm going to plug in a negative, its positive counterpart, and also 0. So I have a negative, a positive, and a 0. And again, when you plug these in, we can use the values that we already generated from up in this previous graph because we had the same parent graph. For -1, we got a 1. For 0, we got a 0. And for +1, we also got a 1, just like when we plugged in -1. So we got a 1, a 0, and a 1 again. So instead of plugging, certain x values into this new function, which is much more complicated because it has x minus 3, then you're squaring, then you're adding 4. There's a lot to do in this new graph. So you can make it so much easier on yourself if you just understand how to shift. Okay, as said, now let's just do one thing at a time. Why don't we do the horizontal shifts first? We're going to act upon our x values using a +3. What x values? The x values from the parent graph. So we're going to add 3 to this, add 3 to this, add 3 to this. And that's to get these new values on the shifted graph rather than plugging in values right into here and doing it. That calculation would be harder. So just 3 plus -1, 2. 3 plus 0, 3. 3 plus 1, 4. We have all our new x values. Other thing we're supposed to be doing is a vertical shift. We're using a +4, which came from there, and we're using that +4 on our y values in order to act upon the vertical shift that we're supposed to perform. On what y values? The y values in the parent table. So very simple. We're going to be adding 4, adding 4, adding 4. So 1 plus 4, 5. 0 plus 4, 4. 1 plus 4, 5. And even if you had gone and taken the harder route, you would still get these answers. Like if you were to plug in a 2 right here, 2 take away 3 is -1. -1 squared is 1. 1 plus 4 is 5. So just with a lot more work doing it that way. So when you're using your parent table to produce the new graph, you're just doing simple addition or subtraction or multiplication. Sometimes that's involved in the problem. All right, so let's look at doing the graphs now so that we can compare the graphs in order to describe what is the difference between the two graphs. You're going to need to be able to do that on the test. So plotting this parent simplistic graph, -1, 1, right there, 0, 0, and then 1, 1. And we see that nice parabolic shape emerging. Again, it's be in your best interest that you know what these shapes are so that you're not connecting the points in some kind of crazy fashion because you don't know what the shapes are. Now, we're going to have a parabolic shape here, again, because the square is on the x, but we're going to be plotting 2, 5. We're going to go 2 all the way up to 5. Then we're going to be plotting 3, 4. 3, 4. Then we're going to be plotting 4, 5. And notice that we have that same parabolic shape, only with respect to this. This is our original parent graph. F of x is just equal to x squared. And this is our shifted graph, which was, let me try and move that over a little bit so I can write the whole function without running into the graph. So this graph that's up in the air is x minus 3 squared plus 4. So notice that this has shifted This graph right here with respect to this one is 3 units to the right, 4 units up. So you're going to describe that. Okay, the G, and I guess I can write it down here, have more room. The G of X function is 3 units to the right of the F of X function and 4 units higher. Or you can say it's got a horizontal shift of +3 with respect to the F of X function and a vertical shift of +4, as we've already stated earlier in the problem. And that's what you do when you're being asked to compare. You're just looking at you're creating a table for the parent graph, then looking at the equation of the other function to see whether there are vertical shifts or horizontal shifts or both. Sometimes the graph shrinks, sometimes it expands, things like that. And then you're performing those shifts on the parent graph table to get the new graph. And then once you have the two graphs and you're looking at them, it's very easy to make a comparison. It's easy to see that this is shifted over to the right 3 units and it is 4 units higher. I'm talking about that vertex right there. It's 4 units higher than that one. Okay, that completes section 2.1.